Okay, so the first thing I see when I look at this problem is that I have a fraction inside of a radical. So that means I can take my radical and split it apart into the numerator and the denominator, which leaves us with the cubed root of 1 over the cubed root of 108 y squared. Looking at just the numerator first, the cubed root of 1 is just going to be 1, because 1 times 1 times 1 is 1. Or if we think about cubed roots, the cubed root of 8 is 2, because 2 times 2 times 2 equals 8. So whenever we're looking at anything to do with cubed roots, we are looking for 3 numbers times itself to be the cubed root. So the cubed root of 1 is 1. And we still have in the denominator the cubed root of 108 y squared. So what I'm going to do is break this up into the primes to find any cubed roots within that 108 y squared. So I'm choose any two numbers that multiply to 108. I would look for, I see 2 times 54 is 108. 2 is already a prime. 54 can be broken up further into 9 and 6. 9 can be broken down into 3 and 3. Those are both primes. 6 can be broken up into 2 and 3, which are both primes. So my prime factorization, if I write this all within the radical, is the cubed root of 2 times 2 times 3 times 3 times 3, and I also have y squared, which would be y times y. And now if you remember back here, we said we were looking for 3 numbers that multiply together to be a cubed root. So I need to look for groups of 3 in my primes, and the only one I see is 3 3s. So those 3 3s can come out to be a cubed root, and I'm left with 1 over 3 times the cubed root of 2 times 2 times y times y. Those 3s were able to move outside of my radical. At this point, we don't want radicals in the denominator, so we need to think about rationalizing our denominator. So I need to think to myself, well, how can I make these groups of 2 be a group of 3? So what I can do is I can multiply by the cubed root of 2 times y. And if I do that in the denominator, I have to do that in the numerator as well, because I essentially just want to multiply by 1, the same thing on the top and the bottom. So now when I look across, multiplying across, I have 2, 2, and 2. So if I put this into one fraction rather than leaving it as 2, I've got 3 times the cubed root of 2, 2, 2, y, y, y. And what I did was I created 2 cubed roots. So those can now move outside of my radical because they are perfect cubes now. I have groups of 3. So those are no longer inside of a cubed root. So if I simplify one more time, I have the cubed root of 2y over 6y.